Good morning. Welcome for today my part 3 of presentation, and I'm still continuing with sampling from where I left yesterday. So today the first part we're going to tackle is what? Sampling error. Then under sampling error we are going to talk about two types of sampling error. That is, we have two types of error in sampling, that is sampling error and unsampling error. So by definition, a sampling error is the error which arises from the difference between which rises from the difference between the value of sample statistic, the value from the sample statistic, and the true value of the corresponding population parameter. It is the error which arises from the difference between the value of sample statistic and the true value of the corresponding population parameter. So for example, we have these two parameters. We have x bar and mu. Now x bar, it is the mean from the sample size n. The mu is the corresponding population parameter. So in order for us to calculate sampling error, we take what? X bar minus mu, that is mean from the sample size n minus what? Corresponding population parameter. So that's how we'll be calculating sampling error. Number 2 is number 1. Number 2, we are going to talk about non-sampling error. So non-sampling error is an error which occurs during the process of gathering the data, regardless of whether a sample or a complete census is taken. So this is an error which occurs during the process. So when gathering the data or during the initial point of data collection, now there is some faulty during the process. Now that's what we call non-sampling what? Error. This is an error which occurs when we are gathering what? Collecting the information. Then after that we're going to talk about sampling bias. So you see, when you're taking census, and actually that's something I've given you something, I'll give you an assignment, and that's one you'll do at your own free time. You'll define what's what. We'll define for me, number 1, census. Number 2, you'll define parameter. And number 3, you'll define sample statistic. Statistic, and lastly, you'll define sample design. So note it. At the end of this topic, make sure you do the definition of the 4. Number 1 is census. Number 2, parameter. Number 3, sample statistic. And number 4, sample design. Now as I proceed with my presentation, now sampling bias. Now let's define what a sampling bias is. Now a sampling bias, this is a type of error. It's also an error. So this is a type of error that occurs when the sample collected is not representative of the population intended to be analyzed. For example, we are collecting a data, we want to do an analysis, yet now that data is not representing the entire population. Now that's what we call sampling what? Bias. For example, this bias can occur. Yesterday we were checking types of what? Types of sampling. And we talked about 2 types of sampling, that was probability sampling and non-probability sampling. Now this error or sampling bias, it occurs more so for non-probability kind of sampling. Like it is when the presentation of the population intended to be analyzed is not presented, the entire population is not captured. Now, factors that may lead to the sampling bias. Number 1, deliberate selection. When the interviewer or the selector is selecting but is doing it deliberately with an intention, so that may rise towards sampling bias. Number 2, substitution of the sample. After the sample have been collected, then the researcher may decide to resubstitute the sample. So that also may lead to sampling bias. Number 3 is the incomplete coverage. So when the area which was predetermined to be covered is not fully or entirely covered, then also that will lead to sampling bias. Inadequate interview. For example, while using what? Let me say stratified sampling. You are to interview let me say quarter. You may to interview the first quarter. Then maybe your quota was around 400, but you only interviewed 300. So meaning the interview will be what? Incomplete. So the intended part, for example, if we were to be used quarter kind of sampling, if the intention was to get 400 sample, but we've only interviewed 300 sample, that leads to what? Incomplete interview. And that will lead to sampling bias. Then to non-random sampling. Now, when we say non-random sampling is because when sampling is being selected, I'm a sample being selected, but with the researcher's judgment or knowledge, meaning the sample does not stand an equal chance of being selected. So when we use a non-random kind of sampling or probability kind of sampling, meaning it leads to what? Sampling bias. And lastly, convenience sampling. And as we remember yesterday, we said that convenience sampling is picking or taking sample based on the availability or the accessibility, those which are available. So meaning when we pick the sample which are available, they may not have met the requirement of the sample that we need. And that will lead me to the next continuation of this topic, but now we'll be talking about parameter and statistic. So parameter and statistic, it is still part of sample, but most of it you will have been covered them in the hypothesis testing. Just for the matter of knowledge, I've just highlighted them so that also I pass a point by it. So we have the parameter and statistics. So I will want us to define what a parameter is. Now a parameter, these are the numerical values that summarizes or describe the characteristics of a population. There's something I missed here. This is characteristics. These are the numerical values that summarizes or describe the characteristics of a population. And statistic, it is statistic, not statistics. So kindly differentiate between a statistic and a statistics. They have a totally two different meaning. Now a statistic is the numerical value that summarizes or describes a characteristics of a sample. So parameter describe characteristics of a population, statistics describe a characteristics of what? A sample. Now I have a small table here that will help you identify between a population parameter and a sample statistic. So for arithmetic mean, now our population parameter will be given by mu. I think you've learned this in hypothesis testing. So this is mu. Then in sample statistics, the same mean will be known as what? X bar. So in population parameter it is given by mu. In sample statistics is given by what? X bar. With standard deviation, in population parameter, standard deviation is given by what? Is given by what? Sigma. This symbol means what? Sigma. Then in sample statistics is given by S, just meaning standard deviation. Now the number of items in population parameter is given by capital N, not capital what? N. So for population parameter, that is what? Capital N, number of items. For sample statistics, you'll be given by small n. So in a question, when you find the number of parameter is given by capital N, just know that it's talking about what? Population parameter. If it's given by small n, it will be talking about sample statistics. If it is by sigma, population parameter, it is S, sample statistics. And that will lead me to the second subtopic, sampling distribution. Now sampling distribution, as I defined, this is the probability distribution of the values of a statistic, such as mean, standard deviation, and proportion, etc. This is the probability distribution of the value of statistic, meaning sample what? Statistics such as mean, standard deviation, and proportion, etc. Then that will lead me to statistical inferences. Mean and standard deviation, we'll talk about them in the measure of central tendency. So I'll cover that topic also, but later in the day, not today. Now, statistical inferences. This is the process of drawing an inference about population on the basis of information contained in the sample taken from the population. So this is the process of drawing inference or conclusion. Inference means what? Also conclusion. So the process of drawing inference to conclusion about a population on the basis of the information contained in the sample taken from the population. So you take a sample, then you analyze that sample, then you give what? An inference or a conclusion. More so, we call it inferential statistics. So we have two inferential statistics. We have two branches of inferential statistics. And number one is statistical estimation. and number 2 is hypothesis testing. So I'll just highlight them: statistical estimation and hypothesis testing. And I'm having an idea you have already been taught testing of hypothesis, the null and the alternative hypothesis, and the calculating t-test and z-test. So I won't major much on the testing of hypothesis, but maybe I'll major a little bit on the testing of estimation. Now let's define what a testing of estimation is. Now, statistical estimation is the procedure. So this is just a procedure, not the process. It is the procedure of using statistic to estimate population parameter. So it's a procedure of using statistic to estimate population parameter. And testing of hypothesis is the procedure. So both of these two branches or concepts are, all of them are procedure. So testing of the hypothesis is the procedure 2, which enable us to decide on the basis of information obtained by sampling whether to reject or accept hypothesis. So there are two conclusions in hypothesis, the two outcomes, that is rejection and acceptance. I have an idea you have already been taught. So with the best of the information you're given, you can decide whether to reject or to do what? To accept. That is what we call hypothesis testing. Now this will lead me to what? Theory of estimation. That's also a subtopic on its own. It's very large, but I'll try to shrink it. It doesn't be too long for you. Now, theory of estimation, under theory of estimation, I'm going to look at two categories. And category 1 will be what? Point estimation. And category 2 will be interval estimation. Now, let's start by point estimation. Let me define. Now, a point estimation is a statistical technique. Now, see, now, point estimation is now a technique, but now, statistical estimation is what? A procedure. So point estimation is a statistical technique used to provide single best value, or sample. Here, after a single best value, you can also, into bracket, we can indicate it to be sample what? Statistic. So single best value or sample statistic for a known population parameter. It's a technique used to provide single best value into bracket sample statistic for a non-population parameter. Now, common points of estimation, I've also highlighted them so that you may know the difference. Now, to connect X bar, we can still refer to this table. Now, X bar is the same as what? Sample mean. Sample mean. Mu, already we are learning to this table. Mu is the what? Population mean. So when you see mu, the question talking about mu, we're talking about population mean. When you see the question talking about X bar, we'll be talking about sample mean. P with a cap. We have a P with a cap. P with a cap. That is sample proportion. Sample proportion. Then P with no cap is what? Population proportion. So for example, we can add it here. So here will be P, and here will be what? P cap. So this is population proportion. This is sample what? Proportion. Hope you're following. Then lastly, I'm going to talk about interval estimation. And this is a statistical method used to estimate a population parameter by giving a range of value. So it is a statistical method used to estimate a population parameter by giving a range of value. So when we talk about a range of value, meaning it is an interval. So into bracket, confidence interval. I remember you've also been taught about confidence interval in hypothesis testing. We have the 95% confidence interval, 99%. So based on whatever interval you've asked, you give that range. So it is the population parameter by giving a range of value into bracket confidence interval within which the parameter is likely to fall. So that marks the end of my part 3 presentation. And thank you again. See you in my part 4 of presentation as I summarize on this topic, sampling distribution. Thank you.